Okay, this is section 7.3, systems of linear equations in two variables. Two linear equations are called a system of linear equations, or a linear system. It is possible to have more than two equations that are also called a system, but I'm only going to make you do two equations. A solution to a system of linear equations in two variables is an ordered pair, or a point, that satisfies both equations in the system. In other words, what we're talking about is the point where two lines cross. It would be a point on both lines. Determine whether the point 1, 2 is a solution of the system. To figure out if this is a solution to the system, it has to be a point on this line, and it also has to be a point on this line right here. In other words, if I plug in the point 1, 2, it has to satisfy both equations. So I'm going to do that. I'm going to take the first equation, 2, and I'm going to plug in 1 for x, minus 3 times, I'm going to plug in 2 for my y, equals negative 4. I'm going to check to see if that's true. If you multiply 2 times 1, you get 2. Negative 3 times 2 is negative 6. 2 subtract 6 is negative 4. And negative 4 does indeed equal negative 4. So the point 1, 2 is on the line 2x minus 3y equals negative 4. We have to check with the other equation as well. So we're going to plug it into the second equation this time. 2 times my x value of 1 plus my y value of 2. Does that equal 4? 2 times 1 is 2. Plus 2, and 2 plus 2 is 4. So the point 1, 2 is on the second line. 2x plus y equals 4. Since the point 1, 2 satisfied both equations, then the answer to this question, is it a solution to the system? The answer is yes. For a system with one solution, the pair of coordinates of the point of intersection of the lines is the system's solution, which is exactly what I've been saying. Before, I gave you a system and I said, is this point a solution to the system? Now I'm going to ask you to come up with the point. So I have this equation here, x plus 2y equals 2. And I have my second equation, x minus 2y equals 6. And what I'm trying to find is where those two lines cross. So I'm going to graph both equations. They are both in standard form. Easiest way to graph when you're in standard form is to do the xy chart and plug in 0 for your x, 0 for your y. So I'm going to do the top one first, and I'm going to plug in 0 for y. So I have x plus 2 times 0 equals 2. 2 times 0 is 0, so I have x equals 2. That will give me 1 point. I'm going to plot that point, the point 2, 0, right here. To graph a line, I need 2 points, so I'm going to plug in 0 for x this time. And now I have 0 plus 2y equals 2. Solve for y. going to divide by 2. I get y equals 1. So my second point is the point 0, 1. And I'm going to connect those dots. So that's the first equation. Now I have to graph the second equation. Again, it's in standard form, so I'm going to repeat the process. I'm going to plug in 0 for y. 2 times 0 is 0. I get x equals 6. Now I'm going to plug in 0 for x. Divide by -2. And you get y equals -3. So I'm going to plot those 2 points. I have 6, 0, and 0, -3. And connect. Now, since the directions say solve by graphing, what I'm looking for is where the 2 lines intersect, where they cross. And as you can tell by the graph, they cross at this point right here. The answer is going to be the coordinates of that point. You have to actually tell me what that point is. So that looks like it's about 4 for the x and -1 for the y. So 4, -1 would be your answer. The solution to that system is 4, -1. Next, I'm going to show you solving algebraically. There's a couple different ways that you can solve algebraically. The problem with solving by graphing is that depending on how well you graph, you may get the correct answer, or you may be close to the correct answer, or you may be pretty far off. Solving by substitution, on the other hand, gives us an exact answer. What I'm going to do is I'm going to look at my system here. I have y equals -x minus 1 and 4x minus 3y equals 24. If you notice, this first equation is solved for y. In other words, this y is equal to -x minus 1. What that's saying is that those two things are the same. They're equal to each other. Since they're equal to each other, one can replace the other. What that means is I can take the -x minus 1 and replace my y value wherever I see it. So that's what it means by solving by substitution. I'm going to take, I still have 4x, that hasn't changed. I still have the -3. But instead of writing y, I'm going to write -x minus 1 equals 24. From here, I'm going to solve it just like I would solve a regular equation. I have the -3 with the parentheses. It has to be distributed. So 4x, -3 times -x is positive 3x. -3 times -1 is positive 3. Combine like terms, 7x plus 3 equals 24. You have to get the x by itself, subtract 3. 7x equals 21. Divide by 7, and you get x equals 3. Now remember, when you solve a system of equations, what we're looking for is a point. I have the x value, but I also need the y value. So what I'm going to do is take the x value that I just found and substitute it into either the top equation or the bottom equation. It doesn't matter. You'll get the same y value. I'm going to substitute it in the top equation because there's less numbers. Numbers are smaller. But it really doesn't matter. You'll get the same answer in the end. So y equals negative. I'm going to replace the x value with 3, the number I just found, minus 1. And you get y equals negative 4. So the answer is a 0.3, negative 4. I'm going to stop here for now. This is the end of part 1. I will start part 2 in another video.